Okay, so what do we have here? So I've kind of literally like reorganized all of this one. So let's have a careful inspection here. So repair works are carried out on the line. After these repair works, the number F of signal failures in a 32-day period is recorded. So what I did is I just renamed the variable. So I said let R for the repair works be a Poisson distributed with a new lambda. So lambda R equals 8 per 32 days. Makes sense? So pretty much it's still the same rate. Still, you know, 1 out of 4 per day in a sense. 8 out of 32 is one quarter. Now a test is carried out at the 5% level of significance. So here we need to kind of pull out the tables to determine whether or not there has been a decrease in the rate of signal failures. So we're concerned if there's a decrease. Now before I even look at the hypothesis, look over here. We always suggest two things. We always follow by the claim. The claim is always H1. That is that lambda is less than 8. There is a decrease in the average rate. So decrease in the average rate to 8 per 32 days. Okay, so this is also one-tailed because when you look at the left side, because it's less than. If it's less than or equal, it will be two-tailed, or greater, one-tailed. The HO is always equal to 8. It's just like a fixed assumption. We always assume it like that. Now, the whole point of this, because we got 5%, we just need to check, you know, when do we reject the null? We're trying to find the probability required that is less than 5% using the tables. Okay, and it always has to take this form, less than or equal, yeah? So that's what the question is asking. State the hypothesis and find the large value for F for which the null hypo should be rejected. Okay, so we're going to reject the null, like I said. So what I did is I went straight to the tables, and we have to keep this in mind that lambda is 8. So going on the tables, this is how it looks like in your formula books. So when you look at lambda equals 8.0, we just go skim down and find the probability which is less than 5%. So less than 0.05. And here we are. Now the greatest one is this one, of course. This is just less than 5%. The next ones are, of course, much bigger. So the one just less than 5%, that represents x equals 3. So when x is less than or equal to 3, when the repairs are less than or equal to 3. So hence we would just say, whoops, that the final answer would be probability R is less than or equal to 3 because that probability is less than 5%. So the large possible value for F is 3.